So I'm thinking that if you could send a chat message now or just before you leave, state your name and organization, that would be great. So
Jeffrey, don't we have a link to Blue Sheets, to like virtual Blue Sheets?
I actually, oh, okay. I guess I missed that one. Can you send a link in the chat window so everyone knows?
Looking for it. I'm not sure what the link is.
Yeah, the other group said there is this shared scratch board where everybody can write at the same time, the IETF thingy tool.
Okay, well, I missed that one, but I guess for now, let's just use, oh, okay, I see that. Yeah, thank you, Pascal. All right.
Now we'll have a thundering herd.
Okay.
Yes, I just adapted from what we're used to. I just made it up, but it doesn't seem to work.
So, are you saying this is okay? So this is just something we just is this the official virtual Blue Sheet thing, or just something we're just using to?
This is from the link we used at other May. Let me dig more, because basically the same sentence, the same structure exists for everybody.
Well, let's just, okay, so let's just do this. Send your name and organization in the chat window, either to everyone or.
But InGen fixed it.
Yeah. Okay. All right then. So it's working now. Okay. That was InGen. That's for the LSR, right?
Yeah. For routing.
Building the internet, one broken website at a time.
Let's just do this. Let's just use a chat window, our own chat window. I'll compile that later. So send in the chat window either to everyone or just to me, your name and organization, and I will compile that later. Let's just move on. Yeah, send it to individual. Yeah, individually to me. Okay, thank you. Either now or before you leave. So moving on with the agenda. So we will start with update on the base spec from Tony, followed by update on the applicability statement by Yuehua. And then we will have a short status update and the plan updates on the working group. Finally, we'll have a presentation from Mariano on the tools for experimenting routing and the data centers. So I did get slides from everyone, but if the presenter could try to share the slides from their own desktop, that would be great. Is that way you can control your own speed when to move on to the next one. If you run into trouble, then I will share from my side. So any other any comments before we move on? Okay, Tony, you can start now. I will stop sharing.
You have to tell me once you see the stuff that I'm pushing up here.
Yes, I see it.
Okay, you see my PowerPoint? Cool. Okay, so let's start. So status update for what are we, IETF 107? Meeting in a more virtual way than usual. All right, so I give you the status update, what was going on between 09 and 12, because now we're converging on ISG review and a bunch of things that we have to follow up on the stuff. So let's jump into that. So I quickly talk about what changed in the draft text. We had some schema changes. Some people were implementing, smart stuff came about, some deployment feedback came back. And then basically my vista for where the base spec stands. So what happened from 9 to 12? So the 12 is not published yet, but it's on the repo. A couple of people were contributing. So first one, I was, lots of readability stuff was going on, and needs. So yes, it's not leaves, it is leaves actually in English. I have been taught, funny enough. We ended up a bunch of glossary extensions. Well, actually not extensions, basically stuff that was there and wasn't either specified well enough or needed some terms which have been introduced without proper explanation. So it's something on main, negative disaggregations, ETP. Then all the FSMs have been moved to text after a little bit of exercise with the XML3 or whatever we have with SVG. And thanks to Bruno for doing all the work. So it's XML2 now. When we publish, we understand the whole thing will have to go to 3, and there's translation tools, and Pascal already went through the process. There was a lot of readability review on basically 4 to 7. I think the stuff before was already down for 9. We had up to 3 people reviewing some sections. A couple of people chimed in. That was actually excellent. We had a couple of people chime in who had experience building actually very large data centers. They were mostly interested in the example section, or yeah, whatever, example section. We reviewed appendices, so that's all folded in. In more detail, I basically highlighted the section that either had some extension on them or they were significantly rewritten for readability, for smoother read. So you see the purging rollovers, weak nonces, examples. Examples have been rewritten like twice. Partitioned fabric. So I got 2 people to review that stuff. But what I mean by partitioned is the basically negative disaggregation fallen. And actually, I had a very smart guy, actually 2 people, that piped in on the host implementation, because the routing on the host is starting to happening. So people are trying to run some kind of first approaches, small daemons, some BGP with default route. And on the host implementation, it wasn't really a technical discussion. It was mostly a discussion to provide something which has the smallest possible attack vector. So basically, absolutely no configuration to run a piece of software which is specifically compiled with something like a hard-baked private key, and from there on has absolutely no configuration whatsoever, and as small attack vector as possible. And then, of course, I had some discussions about the attack vector, then routing on the host presents itself with something like the top of rack. And that is, however, mostly implementation specific. I put some considerations in, but it's really up to the implementation to do the right thing, like having thresholds to basically respond to a host that tries to heavily misbehave. The readability, lots of normative language corrections, some discussions, the usual must, should, may. So that has all been done. There was some discussion with Alvaro, Jeff, I don't remember someone else. No, I think it was just Alvaro and Jeff about how we roll the model forwards to IENA section and how do we put it into registries. And sorry, Alvaro's take was that we should have a registry per Rift major version. So if we roll Rift major version now, and we decide to ref the major, then we have a completely new set of registries, which is a matter of taste as much as anything else, and I'm kind of cool with that. So the IENA section changed significantly, but really it looks like a lot of text. Don't pay much attention to it because being the lazy guy that I am, I have basically Python scripts that take the schema and generates the whole IENA request stuff from the schema. I don't even touch the text. And then massive amount of typos, right? So every time people read, they find more like little twist of grammar or typos. So basically no major changes of algorithms, no massive additions that affect implementation. I would say most output, the most work was done on the readability, most discussions. Okay, so then what changed on the schema? Because people were implementing stuff. I had some deployment experience coming in, people playing with the stuff in partially very weird ways. That's how these things work. So a bunch of major revision bumped up. So we are at 4 now. Kind of meaningless, right? It just basically means it's not compatible with 3. The question that comes up, and I got some questions about that when I was giving them like version 3, why is it 3, right? So, well, OSPF was also version 2. It was never version 1. That's an ancient story. I don't want to explain why, but also the protocol started with V2. So we can start with 4, but we can also reset to 1. I don't know whether people have any preferences or well, it's a matter of perception or anything else, but we are at 4 now. So what happened in reality? Why did we have to bump to 4? For 2 reasons. So let me go to the bottom of the preso. So the first reason was, and that was found in implementation by someone in China. Sorry, forgot the details, would have to look at my mail. We were using version type everywhere. And in fact, the major version type is only 8 bits and the minor version type is 16. So we had a divergence on the model versus the envelope. Or actually, we only had the minor, which was 8. So that was a clear defect. And I had to massage the minor version number and the major version number to split and put the stuff properly in the model, but that moved the size of the minor. So we needed a major ref, which is good. The second one is an interesting observation. So we don't have a checksum on the ties, right? And that has been very consciously done from long-term implementation experience with OSPF and ISIS. The checksums are a major pain in the butt because you kind of have to patch them in at the last moment, right? So basically you have to do the checksum over the whole thing with the checksum 0, and then you have to write the checksum in. And when you verify the stuff, you have to basically play the whole thing in reverse. And since we are serializing the model, we can't patch it in. Well, we could, but it's dirty, right? Plus, checksum are not necessarily cheap to compute. That's probably less of a consideration right now. So we were running fine, but from implementation experience, here's the first, and there were some concerns about it. So the first one is that We do already have origination time and origination lifetime. Well, the origination lifetime is less important, but we have origination time on the tie, which is optional, however, right? But if we do have, so when does the checksum really matter? So the checksum is the last resort. I spent a minute to explain that since I see a lot of people who are probably here haven't been extensively involved. So when we have someone originating, he already puts a lot of info, right? So we have who originated the stuff, which direction, what type, and we also have what is the sequence number, which is rolling around, which we had at 16 bits, which is kind of bad. It's like 60,000, right? In reality, we split the stuff in each half is only comparable to itself, so we really have 15 bits, right, to roll the stuff over, and that's all explained very extensively in the appendix. That's probably the only place in the universe right now you can really find a proper description how the sequence number rolling over mathematically works in those protocols. At least on the routing side. I'm sure other people described it somewhere, but actually I couldn't find it. So the sequence number is fine, but you can imagine very pathological scenarios where you come up and you get something which is the sequence number. Well, the issue is mostly when you have misconfigured network, when you have two people with the same system ID, because normally if people issue, you look at the system ID and you know if it's yours and you didn't originate that, then you just overwrite it. But you have misconfigured network with same system ID, you may have people competing, issuing things, right? And then you simply can't tell because two people look the same, right? They issue the same kind of tie and they show the same originator ID. Everything kind of looks good, right? And you have to fall back on the sequence number. And in something like OSPF and ISIS, it has been done by the fact that you are running basically some kind of CRC, 16-bit, on the packet content, which is expensive-ish. And it's still not 100% secure, right? So if you think you're in the same half of the space, well, so you can go the whole space. But basically, you have some, very, very minor possibility that two packets with different content will end up on the same sequence number. So the first observation was that, well, we already have origination time on the packet. And if you get something, you can compare it with your internal clock, right? Because you assume it's yours, so you originated on the same clock. Or if someone else is running a different clock, it doesn't really matter. What you really just want to see is that the origination time is really what you put into the network. So if somebody shows you a copy, you can look at everything matches, and you can still look at the origination time. And if you realize, well, I didn't put this origination time on this packet, it means someone else originated it, which means I have to override it. So if the origination time is in place, we can actually compare it. They're comparable within a single node, even if two different people originate things. That was the first observation. So there's no harm in saying, well, if you have origination times, you can still look at them. Because the only thing you use them for is to realize, nope, I didn't originate that, right? There's a wrong origination time on it. And whatever it is, doesn't matter. It is like I advertise a checksum, somebody's showing a different checksum on the same packet. Something's wrong. I have to issue a new version. So that was the first observation. And that's kind of just a relaxation of the spec. And no harm there. If somebody doesn't do it, okay, nothing lost. If somebody does it, fine. You basically only use it to realize there is some old copy or weird copy in the network, which I have to override, because you really, if you see something like that, you as a node will originate something with the highest sequence number to override it everywhere. That was the first observation. The second observation was actually even more clever, and the discussion, I liked it to the point where I actually put the stuff in, and I put it on the list, no one objected. So basically, when I look at the stuff, I realize, well, you can just bump up the sequence number to 64-bit. That gives us a huge space, which we can use for a lot of things. We don't have a checksum. So I basically blew it up to 64. And there is a lot of uses for it. You can encode a lot of stuff on the sequence number, actually. You have a lot of bits, right? Because what you really need is just really 32 to like have a huge sequence number. But there's other stuff you can do. I decided to do more than 32. You know, once we blow it up, we can blow it up all the way. So I give you an example. So let's say, okay, I still like the concept of a checksum. Well, you can actually encode a checksum now on 64 bits. And that's, I mean, I didn't put it into spec. It's just an implementation technique, like, oh, I really want a checksum on my packet, but I cannot put it into the model. Well, you can take this 64-bit checksum, and you can basically regard the lower 16-bit as a checksum. Well, sorry, the 64-bit sequence number, and you can use the lower 16-bit as a checksum. And the way you would do it, and it's a simple implementation technique, you would, when you bump a sequence number higher to override, you bump the upper 48 bits. So you kind of don't bump by one, because you're free to bump as much as you want, as long as you do the proper rolling over. So if you use the upper 48 bits, that leaves you 16 bits below. And you can write into the 16 bits a checksum. So you override it by using the higher bits, because it's a much higher sequence number from what you saw before, because the 16-bit don't matter, right? The 17-bit is higher, or whatever, the bits above, so it's higher anyway. And then you use the 16-bit and you just write a checksum into that. So even if you have a misconfigured node that bumps by one and does something, there is basically zero possibility that they will use the same lower 16-bit again. And again, it won't matter because you use the upper 48 bits anyway. So if someone bumps, let's say, the lower 16-bit by one, you look at the stuff and you originate something which bumps up the higher 48 bits, and you write your new checksum in. So you de facto distributing a checksum. But, you know, and I don't put it into spec, it's implementation technique. But the 64-bit allows you all kind of shenanigans. That can you do a sequence number? You can run your clock, you can do all kind of things that you want. All right, then the other implementation, actually deployment feedback was that it would be beneficial if we put the negotiated address families on the link ID pair. Now, people may not be that familiar with the spec. When we advertise on the node tie our neighbors, right, there's a possibility that we have a lot of parallel links between neighbors. So the structure looks like that under the node tie, we have this neighbor with description of the neighbor, and then all the parallel links towards this neighbor that have been negotiated with basically, I don't remember what was in it, just very few things. Actually, I would have to pull out the model to remember. Well, I don't have it loaded right now. So now, we already advertised, for example, where the BFD is up, right? So we can look at the fabric based on the topology database and figure out whether the link is actually up. Oh, and we also have the outer key that has been negotiated. So for every link on the fabric, we can decide whether it has BFD running and whether it is secure, which is actually of a lot of interest to people, because no, it's how do you find that otherwise? You have to go to every node and go and figure things out, right? Now, there was an interesting input. So we are running V4 and V6, and when you do weird misconfigurations, weird configurations, you may end up on a link with only one address family, and the link will be still up. And that is obviously visible on a node, but it is not visible across the whole fabric easily. So when we add the negotiated address family, and it's purely optional element, right? So if you want smaller encoding, you want a simple implementation, you just don't put it on, right? You just because this is, we don't use it for computation. We could, right? So some people got me involved in the discussion, like, okay, so what happens? And that is kind of sidekick of these discussions. what happens if I'm running a fabric where some links are v6 and v4? How will you forward v4, right? Because we do v4 over v6. And now what happens if some links are only running v4 and I'm forwarding v6, and so on and so on? Which, to treat it computationally, one could, but I think it's completely counterproductive to a protocol like that, right? Which is because at the end, you end up with very, very weird algorithms trying to build a partial topology, right? So that I would consider that a misconfiguration, and the only interest is that we detect the stuff. So if we carry the address family on every link pair, right, we can verify that all the links in the fabric are whatever, desired address family, or we can, find out that address family is misconfigured, so it didn't come up. And that way we could detect forwarding holes or, whatever it is. So that has been put on the link ID pair, and it allows us basically to verify that the whole fabric is running the address, the desired address family, or detect any problems. And the problems are really subtle, especially if you start to run something like v6, right, which has basically two addresses, a link local and a global, and so on. People can use it in non-obvious ways, like, for example, check whether v6 is properly configured on both sides in global sense, and basically withdraw the v6 family from the adjacency, and then you will see that the v6 is not working across a link. So that was a little bit long-winded, but I think it was probably of interest to people dealing with finer aspects of deployment in the spec. So are we done with the base spec yet? Yes, we are. So all ISG comments have been addressed. I think the chairs are validating that, but I had the list that had been extensively worked over, and the biggest one was the readability, which at this point in time I think is extensively done. Is anything that we could still like massage and improve? Oh yeah, hell, always, right? I mean, but at a certain point in time we have to get something which people agreed on and start to deploy heavily and interop. The only thing that I see that I try to nudge people, and it's a very boring work, is that the appendix C, which is really redundant, but I was given input by some implementers that is very helpful to go and have something I can look up all the constants on the protocol and which variables should be configurable is in an appendix. So that has been gathered. It is imperfect. So not everything is in it. The stuff that is in it is correct, but it would benefit from some people really going through and adding all the constants and reconstruct the stuff. So if someone wants a short path to fame and the acknowledgement section, which at this point in time grew again, please feel free. Otherwise, I think we are fully cooked with the whole thing. Modulo, maybe some comments on the schema extension that I was talking about, but I took the stuff to the list, and the sequence number happened quite a while ago. I don't think I took the origination time to the list, but I think it should be a pretty short discussion because it doesn't harm. It's purely optional, and you can actually do that even if the spec doesn't say, without violating the spec, because it's up to you to bump a tie that looks like you originated it. You can do whatever you want there. Okay, I think I'm done. So probably a good time to open the mic for discussions. I don't know, up to the chairs.
Tony, I have 2 questions. Can you go back to the previous slide?
Yeah. Mm-hmm.
So you had a question here. Should we reset at publication to major version 1? So did you answer that question, or do you want the people to chime in, or?
Yeah, I want people to chime in. That's more my idea of fun here, right?
Right. So those 4 issues below that, would that are those reasons for resetting or not resetting?
Well, the resetting would be purely cosmetic. I mean, we all moved on. I wouldn't know anyone to running one model anymore, right? So I think the open source is on 3, so we have to pull it up to 4. I was waiting for kind of this discussion and publication of the 12. That's all really easily done, because don't forget, I mean, bumping up the sequence number 64, they can just still run the same logic. And if they don't compare origination time, who cares? And you don't have to advertise the address family, right? So basically nothing there. And the model, the minor version type, this stuff all will correct itself. So those are basically things we have to pull up, and they necessitated to bump to 3 and 4. But at this point in time, since we're putting it at standard, I mean, we can reset to 1. But it's purely cosmetic. Then we can stay at 4, but then, you know, the question will come up again. Why are you at 4? Where's the rest? You know, what did you do? Why are you at 4?
So of the current implementations, is Juniper's implementation a product test yet, or is still?
Yeah, since quite a while actually. Yeah. So
would that cause?
Yeah.
So would that cause a problem if we reset to 1?
No.
Okay.
Because no one deployed 1. That was so early.
Okay. And then for open source implementation, Bruno, what do you think?
I think it's better to start with 4. It's the least potential for problems, and it's not as if we're short on numbers.
And I would concur, you know, but it's just people who were confused. I got the discussion, but then after the OSPF version 2 discussion stopped, so we may as well ignore that. It's not like there's any technical, it's just a fudge factor. I concur with Bruno in terms of being the stuff being consistent. It's better to keep it at 4 and just plow, and help people have to get used to the fact that, you know, this is a different protocol and these things are possible.
Okay. Well, those are the.
I actually think there's a very slight semantic advantage to being at 4. I suspect that the major version number will have to be bumped again at some future point in the evolution of the protocol, because there are, based on practical experience thus far, it's relatively difficult to use things like capability negotiation to avoid bumping the major version number, and having it at 4 puts a thought in people's mind that they should be prepared for other major versions at some point.
Yeah, the capability negotiation, I mean, we did the best possible job, but this is a link state protocol, right? BGP is much better in this respect because you negotiate session by session. So you can run a different protocol version per session, you know, like theoretically. Link state protocols suffer from the fact that everybody gets the stuff, so semantics have to be same for everyone, yeah. And then the capability negotiation basically can be only used to, like, I don't understand it, okay, shut up. But then if you have a mix of nodes, you end up with 2 networks, so yeah.
Okay, so those are the 2 implementations I know of. Well, others, if you have been working on your implementation, and if you feel strongly that we should not, we should reset, and then please speak up. Otherwise, I think we should just keep at the major 4.
Guys from ZT, do you have any opinion? We know you have some preliminary implementation. Please let us know.
Hello, do you hear me?
Yeah. Hey, Sandy.
Yeah, I'm Sandy. In fact, we have no many thinking about the version. We also think the 1 is okay and the 4 is okay. So because this will be the first version of our product. So yeah. So.
Cool. So I know that there's some more implementation work ongoing out there, but you know, I don't know whether people on the call want to chime in. Otherwise, let's put it in the notes. It's good enough. I mean, we have 3 of 3. That's not too bad either, huh?
Bruno and Q.
I had a question about the trick of using hiding the checksum in the lower 16 bits of the sequence number. It seems to me that would break interoperability if one vendor does it and another vendor doesn't do it.
No, Not at all. Not at all. Not at all.
A does it and vendor B doesn't do it, and vendor A receives 5 from vendor B, wouldn't he check a checksum that isn't there, or am I missing something?
Well, don't forget, you only do that if it looks like you own system ID, right? So you can only receive it if the network is heavily misconfigured. So somebody put another vendor's, so let's say 2 vendors, and someone misconfigured and both boxes have the same system ID. So I'm a box which does none of that. So I'm starting with the sequence number 1. It goes to the other guy, he looks at it, says, hey, that's my tie, what the hell is this? And he puts his first sequence number will be something like the 17-bit one, and then below that some 16-bit, which you can consider garbage. It goes to the other guy because now they're in competition, right? It's a heavily misconfigured network where 2 people are competing, trying to override each other information. We're talking here pathological already. I mean, network that is simply not working. Your connectivity will not be working properly no matter what you do. But basically what you want is at the end, you want to finish with a consistent database if somebody shuts down. So the first guy gets something which has the 17-bit one and whatever underneath, right? Because it's lower significance. So he goes, oh, look, looky, I send out this really huge sequence number. He has no idea what the semantics is. He just says, oh, it's a big sequence number. I have to make it bigger. So he takes this sequence number and bumps it by +1, right? The stuff goes to the guy who implements the whole thing. He looks at it and goes, well, look, it looks like a bigger sequence number. He doesn't even look at the checksum. So see, it's not even a checksum, right? So he bumps it by 17-bit +1, so 18-bit one, and puts again 16-bit something, which may be a checksum. It may be purely random number, whatever, right? And the guy who has no semantics gets it, and it looks like a bigger sequence number again, right? Basically, what you want to prevent is that both originate at precisely the same time and bump it by 1. And other people in the network look at it and go like, oh, it's precisely the same information. Whereas it's not. There are 2 different contents. It's just the sequence number looks perfectly the same.
I understand. In that case, if you use the sequence, it won't protect against that release.
Oh yeah, the race will happen. There's no way, because then you would need the system ID of a system ID, right? The system ID basically means that the whole race is only when people misconfigure a network have 2 system IDs, which sounds like how dumb do you have to be, right? And we have ZTP. Well, it's actually quite common because people do weird things that deliver boxes with max, right? Yeah. This race is only purely pathological, right? But also, no, the race is purely pathological. So you implement it, you don't implement it, doesn't matter. It was just like people said, okay, we don't have a checksum. How will I know that somehow by implementation bug, I didn't end up with packets that have different content and same sequence number? And that will protect it from you if you put a checksum. Because next time, if you push a packet out like that, your checksum will be different, 16-bit checksum. I mean, it's not perfect, it's also a CRC, right? But if the content changes, the sequence number will be different.
I got it now. Thanks for the explanation.
So Tony, you spend time figure this out. You spend time explain this in this meeting. Do you think it's worthwhile to write this down probably as an appendix so that's other?
Oh, something like that would go in applicability draft. Look, I mean, you end up with 500 pages, right? I mean, I know people were pushing me from the first meeting, like, please explain how that all works, what is all the rationale. The problem is you end up with the 500 pages, War and Peace, Tolstoy's War and Peace. It's not a protocol spec. If it's worth writing down, there are applicability drafts. There's, you can write like deployment considerations, whatever. I do not think it benefits to start to explain how you deploy the protocol and explain the theory of of everything under the sun in IGPs. So applicability draft, sure. Like have deployment section starts to go and walk all these fine details of how you deploy and misconfigurations and so on. The protocol spec has to make sure that it's correct. And I know we have some considerations in it, like security consideration, which should have been a split document. So it's arguable, but unless people override me and say, oh yeah, no, that has to go in.
So Tony, I would say it doesn't really matter where it goes as long as it finds its place.
Yeah, so I would push
People know where to find
to
it.
the deployment sections. I would push it. I look also for you benefit chairs, because otherwise people will reread and say, oh, look, there's lots of new content. And next thing you have a round of reviews again, which takes you 6 months. And then because this is implementation thing, some people may just purely on style dislike it and then dispute it, right? Because normative language doesn't work, right? When you start to put implementation consideration, oh man, all the hell breaks loose. People have styles and they have likes and dislikes and whatever not. So my frank recommendation, push it on the deployment spec, which is ongoing. And there's nothing wrong there, like misconfigurations and so on. We can put in.
Okay.
I'm fine with it, Jeffrey. What do you think?
Yeah, I'm fine with it. Yeah.
Okay.
Okay. So I have another question. If you go to the next slide. So about that appendix C with constants. Are we going to further improve it before we send it to IESU, or are we down?
Find me someone. I'm more than happy to go and review the stuff. I asked 2 or 3 people, no one had the patience.
Okay. Well, I think let's. So while we're here, if anyone can volunteer to further improve it, that would be great. We'll see. Let's give it a week and see if anyone signs up.
Otherwise, I can just cut it out the spec, because it has been I put it in because an implementer was complaining that he was gathering all the stuff. And yeah, the other comment that I mentioned, I mean, what I'm hearing is like the spec is too big. People are not used to read specs anymore. It's actually frightening. You know, a spec of 100 plus pages is considered, too many notes, if you know my reference. But there's nothing I can do about that stuff. Yeah, so if somebody steps up, fine, we can also cut out this section. It's a pure convenience, redundant information.
Okay, thanks. So that's those are all my questions and comments. Anyone else has any questions, comments before we move on to the next topic? Okay, well, thank you, Tony. So before we move on to the next topic, I see Pascal send out chat message that apparently that sign up sheet is can be used now. So if you haven't, please go to the link that Pascal shared in the chat window. Sign in. That's our virtual blue sheet. Okay. Yuehua, you're next.
Yes, Jeffrey. Would you please show my slides for me, because I cannot open IETF.webex.com on my laptop.
Okay, let me just get it. Tony, can you stop sharing? Okay, I started sharing. Can you see it?
Yes. Thank you, Chair.
Yep.
Okay, so let me know when I should move to the next one.
Okay. So hello, everyone. I'm going to introduce the status of Rift applicability draft. Next page. This presentation includes updates since last meeting and next steps. Okay, next page, please.
Yeah.
Okay. This draft was adopted by the working group in February 2020, and it was updated to working group draft version 01 on April 3rd. And Pascal from Cisco became one of the co-authors. And thank Pascal for drafting 3 new chapters for the latest version. The tremendous modification to the draft was that 5 new chapters were added to the draft. The first chapter was added to 3.2 applicable topologies. The new chapter is 3.3 generalizing to any directed acyclic graph. This chapter describes the operations depending on the direction in rift and states that directed acyclic graph can be used to apply rift. And also a number of caveats are listed in this chapter. 4 more chapters were added to chapter 4, deployment considerations. 3.6 is about positive versus negative disaggregation. This chapter compares positive disaggregation and negative disaggregation with advantages, disadvantages, and applicable scenarios. 4.7 is about mobile age and anycast. This chapter describes scenario of mobility and the deployment considerations of hybrid method in Rift. And this chapter also describes difference of deploying mobile age and anycast nodes. 4.9 is about in-band reachability of nodes. Rift doesn't precondition that nodes of the fabric have reachable addresses, but the operational purposes to reach the internal nodes may exist. So in this chapter, there are 3 cases of deployment considerations. 4.12 is about internet connectivity with underlay. This chapter also introduces 2 cases. Case 1 is about internet default on the leaf, and case 2 is about internet default on the tops. Next page, please. Yes. Next steps for this draft. Comments are always welcome, and I would like to request for working group last call. Thank you, Chair.
Thanks, Yuehua. Any questions, comments?
So I believe we are quite far from working group last call, and thanks for great work. We'll continue working on the document.
Yeah, the stuff still misses a lot of contents, and there's more and more stuff coming up all the time. So, for example, it would benefit from a section where we should describe deployment of horizontal links, tons of stuff like that. Yeah, possibly something how you deploy a VPN over the whole thing, because that's always a very big ask. Yeah.
Okay.
All right. So Yuehua, I guess you can work with Tony and others and get more inputs on the missing sections, and then we can add more content.
Okay, no problem.
Thank you. And so next one on the agenda is the work group status and plan update. So we just heard about the update for the 2 base spec. For the base spec, my understanding is that we're just pending Shepherd write-up, otherwise ready for IESG, especially if we decide to just remove the Appendix C for the constants. I guess we can wait for 1 week to decide whether we see if we get a volunteer for that or not. Either way, we will get it. We will move on quickly after that. So that's my understanding. Do we agree on that?
Well, fine with me. And the C is basically that's probably half a day's work if someone wants to attack the stuff. Just go to the spec, go to the model, get the constants, put them in, all done.
Okay, thanks. And then about applicability statements, so ready for working group last call. Apparently that's not correct. We will keep working on it and add more content. Yeah, model in these updates right now is not. We still need some work, and Sandy has been busy with other things as the main author. So I think we should aim for our working group last call after July meeting or even later, depending on how fast we can see the update. That's how I see it. Comments? Sandy, do you have any thoughts on the timeline?
Hello, do you hear me?
Yeah.
I think maybe before June 30. Okay.
Before June 30, we'll have an update. Okay.
Okay.
All right. Okay, and then perhaps after the July meeting, we will be able to do the last call, or we'll decide at that time then.
Yeah, so there's kind of process to publish young documents. We'll initiate young doctor reviews and all work needed when Sandy provides me update.
Yeah.
Thank you.
And then other works we had stripped off the PGP content from the base spec, and we had the draft on the SR with ripped. On multicast, we did some we did a presentation on how we could do multicast with ripped. I don't think we ever wrote a draft about it. All those work we should get back onto them. And now that the base spec is pretty much done, I hope that people will have more bandwidth for that now. I was actually involved in some of the straps before, and I also have been busy with other things. I think we should all try our best after we get this back down. Let's pick up the work. That's how I see it. Comments?
Yeah, people are apprehensive because it's not an RFC yet. So it will benefit from like, okay, look, here's the standards, you know, proposed standard RFC, it's baked. Now you can go actually and jump into the water.
Yeah. Okay. Jeff, do you have any comments?
Completely in line with my thinking as well.
Okay. Okay. So before we move to the next topic, again, please sign the blue sheet if you haven't. We'll move on to the next one. Mariano, are you ready?
I am. Hello, everyone.
Can you share your screen?
Yes.
Okay.
Can you see my screen?
Yep.
So, hello. And I will talk about tools for experimenting routing in the data centers. These tools are being developed in Roma Tre University. The first tool that I want to describe is Kathará. Kathará is a network emulation system that puts at the user's disposal a virtual environment that can be exploited for tests, experiments, and measurements on networks. Kathará is a quite stable software, and it is an open source software. You can find more information on the website. It is based on three main concepts. Device, which is a virtual entity which acts like a real network device. A collision domain, a virtual layer 2 LAN that interconnects devices, and it acts like a physical link between devices. And network scenario, which is a set of devices connected by means of collision domains. The network scenario provides a simple representation of complex networks consisting of several devices and collision domains. A network scenario is described by a simple configuration language. On the file system, it is represented as a directory which contains a file with the network topology called lab.conf. And for each device, there are files and folders containing the real configuration of that device. As you can see here in the example, we have on the left a simple network topology consisting of 4 routers and some collision domains. On the right, you can see the corresponding network scenario representation. You have a directory with the lab.conf file, which contains the topology. As you can see, each device is described by its name, the number of the network interface, and the collision domain where that interface is connected. And also each device has its own directory and a .startup file. The .startup file is a file that is executed when the device is launched, is started. And the content of the device directory is copied in the root of that device when the device is started. As you can see here, each device has a folder with the Quagga routing daemon configuration, in particular the BGP daemon configuration. Kathará exposes a set of commands accessible through a shell, which allows to interact with it. There are 3 main categories of commands: v-prefixed commands, which are commands used to configure, start up, and shut down a single network device. L-prefixed commands, which are commands used to configure, start up, and shut down a whole network scenario, and general commands, which are used to manage system settings or get running devices information and so on. We're also thinking to implement a REST API server for Kathará to interact with it from a remote endpoint. Kathará is a quite modular software, and can support different virtualization technologies. However, currently it is mainly based on Docker, so on Docker containers. And for that reason, a set of images is already available on Docker Hub. These images are based on Debian and have built-in support for Quagga, FRR, OpenVSwitch, P4/behavioral model. Of course, since we use Docker, you can also use any Docker image available on the internet, or build your own images. As an example, we built an image that contains the Rift Python implementation by Bruno. Currently, there are two different types of deployments: a single node deployment called the Kathará, which uses Docker, and also another type of deployment, which is a distributed one called Megalos, which uses the Kubernetes orchestrator. And a paper for this Megalos will appear in NOMS 2020. With this deployment, we can support up to 5 million devices in a single network scenario. So the second tool that I want to present is the FAT3 generator. The FAT3 generator is a tool to generate Kathará network scenarios for FAT3 topologies. And it is based on the fundamental FAT3 topology parameters, K-leaf, K-top, and the redundancy factor. The routing protocol is automatically generated. Of course, the routing protocol configuration is automatically generated on the nodes that need it. Currently, we are supporting 3 routing protocols: BGP and OpenFabric from FRR routing suite, and the Rift from the Rift Python open source implementation by Bruno. So given the 3 fundamental parameters, we also have the number of servers per rack, and of course you have to choose the desired protocol to use. So given the 3 fundamental parameters, we calculate the number of top planes and the number of pods based on these formulas, which are taken from the draft of Rift, of course. About Rift, you can also add the ring between top planes when the topology is generated. For now, we are only supporting IPv4 subnet assignment to nodes, both for servers and for the whole fabric. However, we will add the IPv6 support for the tool because Kathará already supports IPv6. And also the generated Rift configuration is really minimal. We use zero-touch provisioning. However, if needed, you can always manually edit the Rift configuration files. The last tool is Kathará Test Framework, which is a platform to automatically test Kathará network scenarios. The basic idea is to provide a default test template that is easily extensible and adaptable to the desired scenarios. The basic functioning is to deploy a Kathará network scenario, wait that all the nodes are running, and then undeploy the scenario. However, you can also extend the basic scenario with code annotations, which allow the definition of new methods to execute with a priority in different phases of the test. To create a new scenario, it is only needed to extend the basic scenario, to define some specific methods needed by that scenario. As an example, we can decide to gather some statistics from the traffic or check if the protocol is the routing protocol is working properly, and then we tag these methods with annotation to define when they will be executed in the test scenario. As an example, before or after the protocol convergence, or before the routing protocol startup, and so on. Of course, we integrated both the FAT3 generator and the test framework, so it is possible to automatically deploy and test FAT3 scenarios. The basic functioning of this scenario is to generate a FAT3 topology with the FAT3 generator, then deploy the resulting Kathará network scenario, wait that all the nodes are running, start the routing protocol, and wait for protocol convergence, and then undeploy the scenario. Of course, this is also a basic template for the FAT3 tests, and we already implemented several test cases, such as node failure, node recovery, partitioned fabric, or fallen leaves, and so on. The test frameworks also makes possible to dump .pickup files for each node interface to analyze the protocol traffic and to gather some statistics. Use cases of this test framework are of course, a protocol comparison. For this task, we are actively working with the Uruguay University to compare the most popular routing protocol for fat trees. Our goal is to compare Rift with the other protocols when a quite full protocol implementation will be available. The other use case is the Rift development. In fact, we are exploiting the framework to develop and test the negative disaggregation on Rift. As an example of the protocol comparison scenario, here you have two plots. On the left, you have the number of PDUs, and on the right, you have the size of the PDUs of both BGP and OpenFabric in a network bootstrap scenario. And on the x-axis, you have the key parameter where kleaf is equal to ktop, and on the y-axis, you have the redundancy factor. The radius of the circles are the number of PDUs or the size of PDUs respectively. And of course, the color corresponds to a different protocol. Of course, we want to add Rift in these plots as soon as possible. This is another plot, but the semantic of the plot is the same, but the statistics are gathered when a spine node fades. Now we'll show a quick demo of Kathará and the FAT3 generator to build and deploy a multi-plane FAT3 topology. In particular, we will build a FAT3 topology with kleaf and ktop equal 2 and the redundancy factor equal 1. And the resulting topology will be also deployed and exploited to create a full leaf scenario. So we can also show our progresses in the negative disaggregation implementation in the Rift Python open source implementation. So this is the topology that we want to create with the FAT3 generator. In this shell, I'm in the FAT3 generator directory. The usage is quite simple. You call the main Python file and you pass all the FAT3 parameters as command line parameters. We have kleaf equal 2, ktop equal 2, the redundancy factor 1, the number of servers per rack equal 1, the desired protocol is Rift in this case, and then we also want to add the top rings, so we can declare the top rings flag to create them. Okay, after that, in the FAT3 generator directory, you have this folder, FAT3 Rift, which is the generated FAT3 topology. Here you have three elements, the lab.json file, which contains the information about the generated FAT3 topology. As you can see, for each node, there are the information about the interfaces, such as collision domain, IP address, and IP subnet assigned, the neighbor of that interface, and the number of that interface. Then you have another JSON file, the topology info.json, which contains all the parameters used to generate the corresponding FAT3 topology. And then you have the lab directory. The lab directory is a Kathará network scenario ready to be deployed and already configured. As you can see, we have the lab.conf file, which contains all the topology, and also some additional information, such as the Docker image to use for this scenario, in this case, Rift, and some sysctls to set when the device is started. In this case, we are enabling the multipath on the nodes. We also have the .startup files, one for each device, where we set the IP addresses, and then we start the Rift Python daemon using screen. Also, we have a directory for each device, and in this directory, you have the Rift configuration that, as you can see, is quite minimal because we use zero-touch provisioning. So after that, I open a shell into this directory, and then I can deploy the lab using an L prefixed command called lstart, which starts the whole network scenario. And I also added, oh sorry, I forgot to clean the lab. I also added the -n parameter because Kathará opens a shell for each device in the lab. However, since there are too many devices in this case, there are too many shells, and so I disabled this behavior. Hold on a sec, please. Okay. So now the scenario is deploying. As you can see, it is also quite fast, even if I'm in a virtual machine on a laptop. Okay. Now I have the lab deployed. I can check that all machines are running using a Kathará list command, which lists all the devices of the lab, of the scenario. And as you can see, the output is the devices of this scenario, the status, the CPU usage, and other statistics such as memory usage and so on. So since all the nodes are running, as I said, we want to reach a fallen leaf scenario. So to do so, I will break 2 links of spine 111 towards top 121 and 122. So the leaf 101 and 102 will be fallen leaves for top plane 1. Of course, I already know which interfaces I have to break. However, you can check the information in the lab.json file that is generated by the factory generator. So I connect to the spine using the Kathará connect command, followed by the device name, in this case spine 111. Now I'm in the shell of the device. This is a normal bash shell, so you can use any bash command such as ls or IP route. As you can see here, you can also check that all the prefixes have the multipath next stops as we enabled. And so using IP link, I can check the interfaces of this device, and I have to break ATH2 and ATH3. So IP link set ATH2 down and ATH3 down. Now I'm in the fallen leaf situation. So I will connect to the top 121 and check if the SPF with the east-west links correctly detected the fallen leaves. So I connect to top 121. Okay. Now I connect to the Rift CLI using Telnet. Okay, this is the Rift CLI. And here I type show SPF. Okay, so as you can see, the normal South SPF does not contain the 2 fallen leaves, while the South SPF with the east-west links contains the leaf 101 and 102 with the corresponding prefixes. So now the top should originate and propagate its own negative disaggregation tie. I can check it using show TieDB direction south. So here you can see that the negative disaggregation has been correctly originated. And for now, we set the metric to an infinite value. However, we are still discussing with Bruno if this is the right thing to do. Now that the negative disaggregation has been created, we can go to one of these spines, such as spine 211, 311, or 411. I will connect to 211, and since it received the negative disaggregation type from both top 121 and 122, it should also originate its own tie and propagate it to the leaves. So I will connect to spine 211. I will connect to the Rift CLI here. And I will type showTidB direction south. And as you can see, this is the first negative disaggregation tie coming from TOF 121. This is the negative disaggregation coming from 122 from the TOFs. So now the spine also originated its own negative disaggregation tie, which is this one. So now if I log into the leaf 201, which is one of the two leaves connected to this spine. Now if I do showTidB direction south here, okay, we can also see that the leaf correctly received the negative disaggregation tie. So for now, that's what we have implemented so far. However, all these things should be also installed in the rib and in the fib of the nodes. And this is the next step that we want to achieve. We already created a proof of concept rib and fib to handle the negative disaggregation. However, we are still working on that. And thanks for the attention. Also, thanks to Bruno and Tony for all the suggestions on the negative disaggregation. And if you have any questions, I'm here to answer. Thank you.
Do we have a queue, or can people just chime in?
That's fine.
Okay.
Just chime in.
So, hey, wow, that's impressive. And I mean, you barely started. You already have a good amount of stuff implemented. First observation, I think that putting infinite metric on the negative is a brilliant idea. It's basically, it's one of those things that can, you know, prevent naive or faulty implementations from wreaking havoc on your network. So that's excellent. I think I actually take this stuff up as well. Should we actually extend the base spec? Bruno, what do you think? With a shoot or something?
Yes, I think we should extend the base spec, and I don't see, if it's a good idea, why not make it a must?
Because then you have to explain what happens if somebody doesn't. You know what I mean? That's the problem with the must. I mean, we can discuss it out, but then you go into this, okay, some guy doesn't do that, and then disregard it. Do I still advertise? I don't advertise. What am I supposed to do with these advertisements? What, you know? So careful.
The problem with a should is then you have to explain, at least the way I think of a should is it's like a must except under some circumstances. Now you have to explain what are those circumstances. If you really want to make it totally optional, make it a may.
Oh yeah, I'm familiar with those games. Yeah, I would still err on the side of the should, because everything would work if you don't, right? It's protection against bad implementations that all of a sudden take this prefix and consider it a reachability prefix. But I mean, I'm open to suggestion. But if you want the must, Bruno, then please write the must with what happens if somebody doesn't. And once you start to think through all the cases, I think you go to the should. Because it's not like something. The
current spec has must all over. I don't recall seeing for every must a description of what should happen if you don't do it.
I mean, you can cover a multitude of sins with saying, you know, must send in a particular way, and must accept, you know, all sorts of nasty, messed up stuff. Go ahead.
So here's the thing: if we are loose with the language about what the metric should be, then in the demo that we just saw, the leaf, and let's say that the leaf has two spines on top of it from different vendors. Yeah. If it gets two different metrics, that's going to be even worse. Now they're not going to be
アカウントなしで入れないんですよね。
Well, actually, so let's drill down.
マイクロソフトって昔からそうですけど、でもなんかマイクロソフトがアカウントなしで、入れる
of the Microsoft
システムをこの前出してましたよね。スカイプでもなんでもない。
Can the host mute Hiroshika? There you go. Thank you.
Yeah. All right. Well, so yeah, correct. So John is actually perfectly on the point. You can cover the multitude of scenes by saying what he said. Basically, you must send this, but then you write you must accept anything. Right? So I would err towards that. You follow me, Bruno, right?
Well, it seems like the previous point that the spec is full of musts, and there isn't language for every must what you should do if you don't follow it. Must is must, so if you don't do it, it's a
Well, yeah.
Because when it's a must, it's a must. I mean, there is no way of not doing it because it's a must. I thought it was the should which really causes the problem that you have. If there is a should, it means that some people don't do it. And then, as was said, I mean, you need to say, oh, but if it's not done, what do you do?
So fine. So let's go more towards. Let's take one step back quickly. The metric on the negative disaggregation is really meaningless, correct? So it's just an artifact. We advertise it.
Yes.
Correct. Anybody has a model in front of them? Is the metric optional, or is the metric on the model required? Because that's what we talk about is now the semantics of it, and then we decide how to encode that into procedures. Anybody has the model in front of them? No, they don't. Okay, let me go and dig out the model. Where's the model? Where's the model? Encoding. Here we go. Okay. The metric is required, so we have to advertise something. Okay, and it would suggest to advertise a default distance. So we basically want to take out the semantics of a valid metric away. And what will represent it in the best way? I think we can do a must advertise infinity. And I think on the receive side is what John said, must accept anything and disregard it during computation, because we don't take the metric into account of the negative disaggregation at all, right? It's purely a hole punching, or am I incorrect?
I agree with you, Tony.
Okay. So I'm fine, like if we roll it that way, because the must accept anything basically is the card free from jail, as John says, right? Okay. So I suggest the language on the list. Sorry, Bruno, I didn't understand you.
It works for me as well. I'm okay with that.
Cool. So thanks, John, for chiming in. Yeah, I forgot that there is this escape hatch. So otherwise, yeah, pretty cool. I liked it a lot. We'll probably look at the stuff in more detail. Nice tool.
Thank you.
Great. Thank you, Mariano. It's not only a good tool, but also triggered a discussion on the base spec.
Yes.
Thank you.
Yeah, never thought of that stuff. So last questions maybe. So basically, when the whole thing is set up, you also pump data traffic through that stuff, right?
Sorry.
You are setting up, Mariano. You are setting up the full forwarding plane, right? So you can send data traffic through the whole thing as well, right?
Yes, of course. Each leaf has its own server, so you can also, with Apache started, so you can also check if the connectivity between a server and another server in another pod is working. And we already, as an example, we already tested the trace route, Paris trace route, to check the multipath policies with Drift and so on. So yes, the connectivity works as a real network.
Cool. So here's an interesting discussion now. I mean, I have my own experience thing, but what did you see on the support for, you know, like Rift is doing bandwidth load balancing? Did you do anything with the stuff in the Linux kernel? I assume you did not, right? Because nothing else supports them.
No.
Okay. Yeah. Because that's something where the Linux guys, you know, are facing a slightly new problem. You know,
Okay.
I'm dealing with the stuff. Yeah. No.
All bandwidth that's ECMP is not even implemented, not even for the normal case.
I see.
But
Okay.
it's a question if you. Tony. Sorry, go ahead.
No, go ahead, Bruno.
I have a question. Will be that your answer is it's an implementation matter and you should decide for yourself. But one of the things I'm thinking about right now for the implementation is if we have both normal positive prefixes in that database and negatively disaggregated prefixes in the TIE database for the same prefix, should that be two different nodes in the SPF tree or one node combined in the SPF tree, or you think it's an implementation matter?
Well, I mean, the only thing that the spec has to regulate is the prefix preference, and that is the time breaking is defined in the model, right? And the rest is a pure implementation preference.
Well, yes, but do you think if I have a positively disaggregated prefix for prefix for next hop 1 and a negatively disaggregated tie for the same prefix with next hop 2, does one win over the other, or do I have one node that has one positive next hop and then negative next hop? Leaning towards the latter.
You mean well, the only thing is matters how you construct the RIP, right? And the RIP is just has this one next hop and the other one is taken out. And that's the only thing you really care about. How you implement getting to this RIP is really implementation, preference. So I'm not following you precisely. Which context are you asking the question in? Is it the question of the local RIP, or is it the question about the database, or I'm kind of lost?
So it's clear what the RIP should be.
Right.
It's also clear what the fib should be.
Yeah.
And it doesn't say anything what how the TIDB should be implemented. And so I suspect you're going to answer it's an implementation question. But if you did have a preference, it would be interesting to, as an implementer, you could say whatever you want. It's your call. Or you could say, based on my experience, this is not a good idea to do, or this is a good idea to do, etc.
Well, so the way, okay, so if you ask me for an opinion, the way I attack those kind of things, I'm running. So you run an SPF which covers nodes first, right? You do the same thing. And then you run prefix expansion, correct? Right. So I'm running stuff that gives me the necessary node closure, right? And the problem with that, it's very hard to parallelize. You can, but this kind of computation is very hard to parallelize. This computation can be done incrementally. Those are all sophisticated implementation techniques, right? Once you have that, then you start to attach prefixes. And for me, it's a blind thing. You have all these prefixes, you just gather them together because you have any case cases, you have, unequal cost cases, like you don't want to bother, you just attach prefixes. Again, this is prone to, so this is very prone to parallelization. And that's why I like it. Just blindly go and gather, just attach prefixes, right? And you can hugely parallelize that. You can also incrementally do that. And that has very large impact on the scale of your implementation. Once I have that, you have all these prefixes, all these different type of prefixes, and you just blindly throw them at the RIP, and you go tie break this stuff. And you don't even look within the implementation of the computation what these things mean. because the tie breaking is a local rip. And the local rip has its own structure where it decides which of these prefixes matters and what are the next hops. And that seems to me to be the more natural way to do things. If during the computation you already try to be smart, and tie break, you mostly fall flat on your face. Because you have so many different types of prefixes and you have different metrics and you have any cases and blah, 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 right? Did that end? I mean, was that what you were looking for, or did I go on a tangent which is irrelevant to your question?
Well, so the parallelization part is interesting, but it was tangential to my question. The answer that you gave is a little bit. The other answer that you gave is you treat the prefixes blindly. You know, here's a prefix. I don't care what it is. I don't try to interpret what it is. I just attach it to the node, and off we go. I'm wondering if that's really possible if you have both positive and negative prefixes for the same prefix.
Absolutely. Observe, you already have a million other prefix types. Negative is not all that special. You already have like disaggregated, external disaggregated. You have a whole zoo. And if you think through the stuff carefully, you start to realize the key value is nothing else but actually a prefix we're sloshing around as well. Just like NLRI is being a I'll
put a specific mailing list that gives a scenario.
Okay.
Because it's kind of difficult to explain over the just talking.
Sure. Okay. No, so that's the other reasoning why I like to treat these things blindly, because you don't even know whether these things are prefixes. Right? Those are some attributes of a node. And then there is a projection of all these attributes together over all these nodes. And there may be prefixes that guide you forwarding, there may be key value pairs, there may be something really weird. And each of these local rips, call them what you want, which are really just a database, may have different projection rules, which you shouldn't, I mean, it's a my take, which you do not want to leak into computation. Because computation progresses, it builds its own knowledge. And on top of that, you throw the attributes and say like, okay, what is the projection of those attributes? Okay, but let's take it to the mailing list and see what this discussion involves. Because I don't see any asymmetric case here. If you have some asymmetric case where the spec lacks in, proper definition of what's supposed to happen, yeah, then we have a problem. Right? But if that's just implementation, optimization, and techniques, there's a million of them. And again, it's as much as matter of taste often, and whatever, like memory sizes as anything else.
All right, that was quite a discussion. Any further comments? Jeff, do you have any thing?
So we've got a bunch of action points. So Tony to work on applicability draft, help UI Sandy. What else? Bruno is going to send his question to the list, and everybody would benefit from explanation from Tony. And I think that's all on my side.
Okay. All right. So before we close the meeting, once again, if you haven't signed the blue sheet yet, please follow the link that Pascal sent in the chat window. Go there, go to the link and sign the blue sheet. So we're done for this virtual meeting then. We'll see you.
So one input from a bunch of people playing with the stuff was, and looking like no serious deployment was, where's the multicast?
Well, okay, that's cool. It's good. It's good to hear about that question, because quite often people they just struggle at the multicast. So indeed, we have an idea of how multicast will be done, and we actually presented it before. We just need to turn it into a draft and then get people review, discuss. Yeah, we'll get that work started.
Yeah, I'm slightly nudging because I saw that you guys will be at certain point in time up to what you call it, to agenda redefinition. So it's always good to have ideas, rather than let you being driven in some directions. So I've probably had the feedback about 3 times that people were interested. If you could have multicast in it, it would be a very interesting thing for them. About 3 times. Yeah.
Tony, how about segment routing? Has anyone brought it?
No use cases. It's that simple. If I ask people, what would you use that for? The answer is none. Okay. I mean, so because most people, what I'm seeing, and that's pretty much universal, is people start whatever segment routing on the host, and it ends up on the DCI gateway, which is either top of the fabric or another. Which practically speaking means that you run SR over UDP. Just like MPLS over UDP.
Yeah.
And that's all. For that, you don't need Rift. That's a purely basically overlay thing. And the other use case is error triangulation. But I mean, there is no SR silicon, frankly. Well, I mean, what I mean is like cheap enough to push it and scalable enough to push it into Fabric and Relay. Because at the end, I mean, if you look at segment routing implementation, these are very expensive silicon, high-end silicon.
Not for MPLS ones.
MPLS didn't scale for data centers, so you can have this discussion with a bunch of people. Everybody gave up because the silicon didn't scale.
So my question is context of priority with regards to future work. We've got multicast, we've got segment routing,
Let
some
those
other
people
stuff.
come in and define use cases.
Okay.
Right, because everybody asks for the moon, especially if they want it made of cheese and not pay for it. That's the prerogative, but it does not mean that it makes sense to do that. Traffic triangulation, yes, SR could solve it, but there's way simpler solutions. So people are just running around with the hammer looking for nails. But my personal opinion, okay. And all the engineering I'm saying, practically speaking, and it is good enough, is you start from the host, and that's a valid thing, and you shove it over UDP, which the fabric will do on the cheapest silicon. On the edge of the fabric, that's where you do all the smart stuff with SR. And nothing wrong with that, right? But why should Rift get involved in distributing these SR stacks? In a sense, it has no business doing that, because then you load all this huge amount of state into the middle of the fabric where you don't need it for anything.
Okay, point taken.
So if you get this push, I mean, my thing is like, what's the use case? The multicast guys a very good use case. Right? They basically want to push from the overlay multicast into unlay multicast, and because it's so much faster. And that service discovery and whatever not, right? So there I see use cases. On SR, I didn't see a single use case that would, justify doing it, but just me. If somebody wants to attack it, super, okay, perfect. We have an answer.
Tony, with multicast, would it support, this is Guian speaking, would it support eventually ASM and source specific multicast as well? Or
you have much better, you have much better multicast guys on this call than me.
Okay. I think that's good that that's the direction, the roadmap, that you eventually will have multicast. So that's good. That's a good use case.
Yeah, the multicast use case, the multicast idea we talked before is actually based on bidirectional multicast. So yes, it would work for ASM.
Okay. And SSM, I guess, either one, I guess.
Yeah.
The other input, since we're not talking the charter and multicast stuff, so I see a development where I would not be surprised if people run beer on Clubhouse.
Yeah. Well,
The guys who are pushing for multicast are interested in actually having beer at least to the Tor. Yeah.
mhm.
Again, the efficiency discussion, right? Yes, you can do it in EVP and multicast overlay. Yeah, that's fine, but they want something real fast, down native.
Beer to the tour from the DCI or from the. Oh, never mind. Okay, never mind. I'm sorry. I got myself confused. Yeah.
Beer is bidirectional, right? Yeah. Yeah.
Okay. That's again a little bit surprised because yeah, many people they don't even think beer is happening in outside data centers. So good to hear that people are interested in beer in data centers.
Well, the people who want multicast in the underlay, they're mostly obsessed about performance of it, right?
Yeah.
Pushing in the underlay is okay. I can have to make it converge faster than overlay and be more efficient on replication. And then once you have beer, then you basically have it right on the hardware baked in, which is as fast as it can go.
Okay.
Generally, people, I don't know, I mean, other people will have opinion, but generally the people who are interested in multicast, they have French applications for which they have a lot of money. We all know that.
Yeah, I think for the
I did-
underlay bum traffic, I guess that's the big one that helps for the broadcast and then unicast and multicast traffic.
I think I did write a draft about doing beer in Rift as well.
Yeah.
A long time ago. We just need to pick up the work. It has been distracted for a while, but we should get back into it. Now, when there is a good use case for it, we should get onto it.
Well, I think, and I actually like that. Everybody got very focused on the base spec, right? I mean, there was huge amount of work done on the stuff, huge amount of energy. I mean, these 150 pages have not come cheaply, right? So I like that. But now, once the base spec is cooked, I mean, it's up to you guys to define the next generation, you know, or next charter thing that we should be pushing. And I'm just giving you some feedback.
Tony, back to beer. Signaling between server and top of rack MLBI GMP, or it's beer to the host?
Well, so they don't believe the beer to the host will happen in foreseeable future. It's always discussion of silicon, right? They want beer to the Tor because that will already make them like infinitely better than what they're doing today, which is mostly doing either unicast replication or doing multicast and overlay.
Okay.
Okay. Anything else? If no more, then we'll close the meeting. Meeting adjourned. See you on the mailing list and on the air in July.
Thanks, everyone. Keep safe, and we'll talk to you soon.
Thank you.
Bye-bye.
Bye.
Bye-bye.
Bye bye.